chapter. From this chapter, students, a very easy chapter and very direct questions comes. Balance, unbalanced, right? The questions which we did in between. Laws of motion are very important from this concept, and plus this. So we will be practicing few questions. Jeva, you already did it, but it will be a revision for you, and then we'll just do 1 or 2 questions. Okay, and after that we'll just quickly move to the next part. Okay.
Okay, ma'am.
Okay. So this is for Adil itself. Adil, because like I explained this to Jeba because I took her extra class. This for Adil. Okay. So see, Gogi pushes a scooter for 4 seconds, right? The scooter gains velocity of this. Find the force applied. Okay, so you have to find the force applied over here. So very simple. First of all, over here time is given, right? And what is this? Velocity is given, right? And also mass is given. So first of all, you need to find A, right? Because force is M into A. So M you have, you need to find A. How you can find out A? V minus U divided by T, right? So what is your V? It's 8M. And what is your V? It is 0. Why? Because U pushes his scooter from for 4 seconds, the scooter gained velocity. So at that moment, your initial was 0. And then he started moving at the 4 meter, right? So it is 0. So it is 8 minus 0 divided by 4, 8 upon 4, your answer is 2. Clear? And what is your force? Now you have mass, now you have this acceleration. So 10 multiplied by 2, it's 20 Newton. Clear?
Yes.
Okay, so quickly write it down. Then we'll just do one more question for this, then we'll start with the question answer. Students, one more thing, like tomorrow class I'll be postponing. I'll be taking your tomorrow's class because tomorrow I have to go for some award function. So I'll be taking your this class, like tomorrow's class on Friday. So I don't want any one of you to miss the Friday's class. Like we'll be meeting on Wednesday, and after Wednesday we'll be meeting on Friday. Okay.
Okay, ma'am.
Done.
Okay, good. Now, next question, you have this one. Gogi was driving at 20 meter per second. He applied brakes. He generated the force equals to this. Find the distance after which the car will stop its mass to this. So over here, first write what you have. You have speed, you have force, which is minus 500, and you have your this mass, 100 kg. Okay, so first of all, what you have to find? You have to find distance. That means you have to find S. This chapter and the previous chapter, they are related. So you are going to link it. So first of all, over here you have force, you have M. So first of all, you will find A from here. Your force is minus 500 and your M is 100. So you will get A equals to minus 5. Now you have to find S. So you have lot many definition for it. So you will put this one. You will put A minus 5 and S you don't know. So it is multiplied by S. V square, 0 square because there is no V. But U it is, which is your 20. Right? So 20 square. So it is 0 square 0. 0 minus 400. So you got minus 400. Okay, and it is 10s. So when you will divide this, you will get 40. Clear?
Yes, ma'am.
Yes.
Quickly do it, then we'll start the question answer. Okay. So let's just start with the question answers. Okay. Justine is also here. Good evening, Justine. Okay. Can you see my screen, students, now?
No, ma'am.
No. Wait. What's wrong? Yeah. Now I think you can share.
Yes, ma'am.
Okay, good. So now page number 18, we have the question. Which of the following has more inertia? A rubber ball and a stone of a size, a bicycle and a train, 5 rupee coin and a 1 rupee coin. Okay. So first of all, you should remember that how inertia is measured. Inertia is measured by the mass of the body. We did it over here when we were writing notes. Yes, higher the, you remember this? Heavier the object, larger the inertia. Right? So this is we are going to apply over here. So inertia measured by the mass of the body. So over here, rubber ball or the stone ball, which will have larger inertia? Tell me.
Stone ball.
Inertia is measured by the mass of the body. Mass means what is the weight of the body. Like not body, like any object. Okay. So first is rubber ball and the stone ball, which will be heavier? Rubber ball or the stone ball?
Stone.
So girls, only Adil is getting. Girls, stone ball or the rubber ball?
Stone.
Which will be heavier? Stone ball, right? So the inertia will be higher for stone ball. Second, a bicycle and a train. Who will be higher? Which one?
Train.
Train. So inertia will be high for train. Then a 5 rupees coin and a 1 rupee coin. Which will be heavier? Of course, a 5 rupee coin. So inertia will be higher for 5 rupees coin. So you won't be writing everything like this. You will write question number 1, page number 118, question number 1. Then you will write inertia is measured by the mass of the body. Inertia is the mass of the body over here. So A, you will write stone ball will have greater inertia. Second, you will write train has greater inertia. And then 5 rupee coin. Here you are not going to write everything. Just write in short. Okay. Be very quick. You can write it down. Okay. Girls, you are also done? Jasleen and Jeba done?
Yes, ma'am.
Okay. Now, question number 2. In following example, try to identify the number of times the velocity of the ball changes. Okay. So, a football player kicks a football to another player on his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks toward a player of his own team. Also, identify the agent supplying the force in such case. So, over here, first, what is happening? Football is going to the first player he kicked the ball, so one here, and then again keep it to the goal two, and then he again kept it to three, like the opposite team player third time, and he kept it to like he kicked it to the own team. So how many times the velocity is changing? The velocity of the ball is changes 4 times. Clear?
Yes, ma'am.
Okay, quick. Done.
Yeah.
Now, next, explain why some of the leaves may get detached from the tree if we vigorously shake its branch. So you have seen that most of the most of the leaves which are weak and something, they just fall down when you shake up the tree, right? So why? Some leaves of the tree get detached when we shake its from branch vigorously. This is because when the branch of the tree are shaken, it moves to and fro, but its leaves tend to remain at rest. This is because the inertia of leaves tends to resist the to and fro motion. Due to this reason, the leaves fall down from the tree when shaken vigorously. Clear?
Yes.
Yes, ma'am. Done, ma'am.
Done.
Okay. Now, next question. Why do you fall in a forward direction when a moving bus brakes to a stop and fall backward when it accelerates from the rest? So, due to inertia of the passenger. Clear?
Yes, ma'am.